Okay, so everybody, we're going to do one video today here for the z-scores, which would be discussed for your second integrative assignment. In your integrative assignment here, if we pull it up, you would be asked to, let me see, over here, you'll be asked to calculate the z-scores for the voyage octon using the mean and standard deviations you found in SPSS. So I'd like to do more on the z-score right here real quick. So as for z-score, basically we've done some of this score computation in normal distribution. A z-score is the number of standard deviations that a given value x is above or simply below the mean. When z-score is positive, so when z is positive, that means the value x is simply above the mean. If your z-score is negative, then it means your value x is simply below the mean. Computation of z-score is followed by these two examples. The formula, you know it quite well. So z-score equals to x value, okay, your data value, subtract the mean. For sample, it's x bar for population's mu, but in general, x minus the mean, and then divide by standard deviation sigma, or s for samples. For z-score, we typically round it to decimal places. Okay. Some important property of z-score. So z-score indicates the number of, okay, so z-score indicates the number of standard deviations that a given number is above or simply below, as we mentioned. Z-score comes with no units of measurement. So we don't say z equals 2.31, some units followed by that. We don't say that. It's just a number. By using the z-score, you can tell whether your data value is above or simply below the mean. Compare your x with the mean. And typically, the z-score can help us to identify whether a value is extremely low or high. Okay. So thirdly here, a data value is significantly low if the z-score is less than or equal to -2, extremely small. And the data value is significantly high if the z-score is greater than or equal to +2. So by looking at the z-score, you can tell whether a data value is extremely high or low. Okay. This helps us to identify the outliers as well. Now, the last property, as we mentioned, which we've said, if individual data value is less than the mean, then the z-score is going to be negative because we have x is smaller than the mean. We have one example here. First example, comparing a baby's weight and adult body temperature. So we have, I'll give you 30 seconds to read the problem. Okay, so the problem talking about two data value. We want to see which one is more extreme relative to the data set from which it came. So the first data we have here is the 4,000 G, 4 kilogram weight of a newborn baby. Okay. So 4 kilogram. And this is among 400 weights with sample mean x bar 3152 gram and a sample standard deviation of s equals 693.4. So this is a baby weight in 400 weights. And the second data value we have is 99-degree temperature of one adult. And this is in 106 adults with sample mean x bar equals 98.2 Fahrenheit and sample standard deviation s equals 0.62 Fahrenheit. So we're comparing this 4,000 gram weight with 99 degrees temperature to see which one is more extreme compared to its data set. So over here, the way we can do it, of course, baby's weight can not be typically compared with the adult temperature, but we can see which one is more extreme by comparing the z-score. So let's compute the z-score for the baby weight, and we can also compare the z-score for this adult temperature by using the formula. So let's convert each of these birth weight and temperature to their z-score. Again, the formula is the data subtract mean, and then we divide by standard deviation. So for the baby's weight, okay, so baby's birth weight, if we apply this formula, 4,000 grams subtract 3,152 grams divided by 692 is 1.22 for z-score. So it's 1.22 standard deviations above the mean. Right, standard deviations. Now, 99 degrees body temperature, the z-score turns out to be 1.29. So it's still greater than 0. So the z-score indicates 99 degree is 1.29 standard deviations above the mean. Okay, so we can put this in summary. We say the z-score shows that 4,000 gram birth weight is 1.22 standard deviations above the mean, while the 99 degrees body temperature is 1.29 standard deviations above the mean. So both are like above the mean, but we can tell 99 degrees is 1.29 more standard deviations above the mean. So this 99 degree body temperature is slightly more extreme than our birth weight of 4,000 gram. So the z-score can be used to identify the significant values. If your z-score is between -2 and -2 for the data, it means the data value is not significant. If the z-score is greater than 2 or less than -2, then it means the data value is significantly high or significantly low. And so just in connection of your integrative assignment 2, when it comes to the Ogden data, you can compute the z-score to see if the z-score is high or low. Okay. Again, if the z-score is greater than 2, then you know this variable is significantly high. The Ogden trip is significantly higher than the other voyages. If the data actually turns out to have a z-score less than -2, you can say the Ogden voyage has a significantly low value compared to the rest of the other voyages. Okay, that's how you use the z-score. Okay, so next part, we're going to talk about the SPSS part of your integrative assignment number 2, which first of all, you will need to get the data from this voyage's website. And you guys all know how to do this in general from assignment 1 and assignment 2. Now, suppose this is a data set you have already got, a voyage list. Remember, you can get the variable name by looking at the list of variables that you have selected. Okay, so these ones will tell you which variables you have selected. This is particularly important if we are looking at your SPSS data file. So you will get a bunch of variable name as mentioned, but some of these variables names are very hard to understand what they're about, such as this SLIN intent. Okay, if I just look at its name, I probably don't know what that is about. So you make sure you put the label over here in this empty cell. And again, the way you get these labels is just going back to this list of voyages, the selected columns for the variables that you have used. Okay, so over next, we're just going to go over some of the requirements real quickly. Okay, first of all, you are asked to choose at least 2 qualitative variables, qualitatives from this list, and at least 2 quantitatives from this list. And we need to do the frequency analysis as well as for qualitative and quantitative. So let me just show you real quick. You will probably be familiar with this simple steps that we've been going through. First of all, let's suppose we're looking at a qualitative variable. Okay. So qualitative variable means it's categorical, okay, such as the region of slave purchase. Let's take this for example. Okay, so we go analyze and descriptive stats, and you go frequencies, right? And we can say the region. Let me just move this here. So suppose this is the principal region of slave purchase. So move it to the right. We display frequency tables. And again, make sure in the charts, this is categorical. So we do bar charts instead of histogram. So check bar chart. And we can do percentage to see what's the percentage has been covered for each region. Continue, hit OK. Alright, so this will be the output of the SPSS, tells you the principal region of slave purchase. Once you have put the labels in for each variable, okay, once you have put the labels in your output, you should be expecting to see the labels being shown up. This is much easier to see than the variable names. So you would have Asia and Benin and Gold Coast, different kind of regions being displayed. And this is going to be the bar chart. And we need to talk about what's your voyage, which is the Ogden, based on the project. Which region Ogden voyage is based on, okay, where is the region of slave purchase for that particular voyage, and compare that voyage compared to the outcome. If the voyage happens to be in this bar, then it is one of the most frequent used region of slave purchase. If not, then you can also say something about it, right? So that's about the categorical data, okay, variable. And we can also look at quantitative, right? Such as, let's see, now, such as this variable total slaves embarked, so which means the total slaves on board, right? So again, you do analyze descriptive stats, and this time we do explore, okay? And you're going to move that variable over. You can enlarge this to see what variables you have, okay? So I'm going to say that's the total slaves embarked, move it over to the right. For statistics, you have descriptive stats already checked in, so hit continue. And for our simple plots, we do not wish to have stem and leaf. So if you have this checked, uncheck it and check histogram. Continue and make sure you have both, so including both stats and plots. Hit OK. Alright, so that's going to be your output. And based on your output, you're going to write up some conclusions, such as, okay, the mean number of total slaves embarked is 330.84. And what's the median, what's the minimum, what's the maximum, and what's the range, right? These are some things you need to discuss. Also, when it comes to the histogram, from your feedback of last time of your SPSS assignment 3, we have said you're going to describe what's the shape of distribution here. That's right skew. And what's the most of data are accumulated from this value to this value. I can say most of the number of total slaves embarked is from, say, somewhere, this is 230 to like 500 and around 600, things like that. And you also need to say something about the box plot, especially about those outliers, right? We have outliers here. One is, say, almost 1500-ish, and also outlook in the outlier that's slightly above. So to the very end, we'd like to try to connect the problem once again about the z-score here. Let's see the z-score. Where is the problem here? So the question asks us to calculate the z-score for the Ogden using the mean and standard deviation you found in SPSS. So if you have reached this output page, you can get the mean 330.84 and standard deviation 180.159. By the way, the standard deviation here is really big compared to the mean. That means your data are quite widely spread out. So for using the z, we're going to find the total slaves embarked for the Ogden voyage. Okay, and you need to look for that on yourself. So total slaves embarked for that Ogden voyage. and find that specific data value. And we use the formula z equals to x minus mu divided by sigma. So find that value, subtract the mean, x minus mu, and then simply divide by standard deviation. That's going to give you the z-score for the total slaves embarked on that arc-down voyage. And based on that z-score, you can tell whether that arc-down voyage is having extremely high total slaves embarked or low total slaves embarked or just normal. Okay? That's how you're going to use the z-score. And again, make use of the mean and standard deviation from the output. Alright, so that should be the end of the integrated assignments guideline. Let me know if you have any questions. Okay, thank you.